All right, so let's take a look at this. So we have this language, and I decided, well, I said you get to decide what a reasonable parser for this would be. So maybe we call this type of element we call this maybe num stuff. And we call this type of element maybe sim stuff. Something like that. Okay, and the whole thing is a list of stuff, so we're going to go through every element in the list and determine what kind of element it is and rebrand it, right? Okay. So let's go into here. We can define parse list O stuff to be a lambda that takes in a list of stuff. And what we're going to do is we're going to go through that list of stuff and build up a new list that has each element of that list replaced with the type of stuff that it is. So we're adding semantic information to each of the elements. So we'll ask the question. So cond null LOS. So if we're out of stuff, go ahead and just return the empty list. Otherwise, we must have something. If car LOS is a symbol, return the list containing sim LOS, something like that. Or maybe just, what do we say in this thing here? Sim stuff. Call this sim stuff. Followed by what the stuff was. Car LOS, so that's what we'll return for sim stuff. Else must be num stuff. So return a list, num stuff, followed by the car of LOS.
Like, only return for the first value, though.
You're right. So this gives us that list. And what do we want to do with the rest of it? We want, because we're going to have a cdr to this, we need to parse the rest of the list, right? So we're going to cons this guy onto whatever's returned for parse list O stuff on the cdr LOS. And we'll cons this stuff onto whatever is returned parse list O stuff for the cdr LOS. Like that. Now, how else could we have written this? Because of the nature of what we're dealing with here, we actually could have used map for this. So we could have said, if we want to write it as a, we'll call this guy map function. This is going to be a lambda that takes in a single value. It asks the question if symbol x, then list sim stuff followed by x. I'm going to kick that down a line. Otherwise, list num stuff followed by x. So that's what that map function would do. And then we would say define parsed list O stuff 2, for example, would be a lambda that would take in a list of stuff, and we would return map function over the list of stuff. So it would apply this map function to each element in LOS, replacing it with either the list sim stuff x or the list num stuff x. That makes sense? So either one of those is a reasonable solution. If you wanted to make it harder to read, you could have grabbed this lambda right here and replaced map function with that. It would just look scarier. But it would have been effectively the same thing because that variable is going to resolve to that exact thing. Okay, questions about that one? All right, so this was pretty related to the homework assignment, right? So if we look at our homework assignment, we had this was exercise 2.31, right? And we were supposed to write parse and unparse. Okay, so this guy, we have this thing called a prefix list, which is a list of prefix expressions, okay, where a prefix expression is an int or it's a minus sign followed by a prefix expression followed by another prefix expression. Fair enough? All right, so that's what this guy is going to be. So things like this match up to that. Now, what we want to do is we want to create a parser for that such that things that start with a minus are referenced as diff expressions. And when we see a diff expression, what do we expect the next two elements to be? Prefix expression and prefix expression? That makes sense? All right. Now, so we need to have a function maybe called getPrefix expression. That could be one way we could do this because we don't necessarily know what type of prefix expression the next guy is going to be. So when I hit, for example, when we hit this minus sign here, I know that this guy's going to be followed by two prefix expressions. Now, the very next value is going to tell me what the type of the first prefix expression is, right? But I kind of have to go down that rabbit hole until I can get to the rest of the prefix expression because I don't know how many diff expressions I'm going to have to go deep to get my left diff expression of this guy. So for instance, in this case here, here's my first diff expression I run into. So it's easy. When we see a minus, we're going to start with diff expression. That's the easy part. But then we need to have whatever's returned for prefix expression. Parse prefix expression for this next piece. Okay, so this next piece is going to give me what? It's going to give me a diff expression followed by an easy, two easy prefix expressions. So this is going to be diff, whose left side is a diff, whose left side is a 3, and whose right side is a 2. So that's going to be the left-hand side of the first diff. Right there. Make sense? The right-hand side of that is going to be a diff expression whose left-hand side is a 4, and whose right-hand side is a diff expression whose left-hand side is a 12, and whose right-hand side is a 7. All right, so one issue we have here is we don't know how many of the next parts of the list we're going to have to consume in order to get to the, until we've cleared out the list enough to get to the right-hand side. Does that make sense? So would it be helpful to have a helper function that extracts the next diff expression from a list? Might that be handy? Whether it's a single element, so if the car of the list is a number, it's easy, right? If we just return the number, there's your diff expression. Otherwise, what are we going to return? We're going to return the full, well, we might return a diff expression. That makes sense? And at the same time, we also need to start paring down our list so that we don't accidentally use the same expression or same, what do we call it, prefix expression more than once. That makes sense? All right, now they gave us a hint here, right? I think they gave us a hint somewhere in the bottom. As a hint, consider writing a procedure that takes a list and produces a prefix expression and the list of leftover list elements. Okay, so it gives us kind of a two list. The first element of the list is going to be the prefix expression that it extracted, and the other stuff is going to be the rest of the list that's left over after it extracted that prefix expression. Make sense? Okay, so if I come in here, and let's just write that first part first. So let's create a define. What's this guy called? A prefix expression. Let's call it get next prefix expression. That's good enough. Get next prefix exp. And this is going to be a lambda that's going to take in a prefix list. Actually, why don't we just say it takes in a, well, prefix list is reasonable. This guy's going to take in a prefix list. All right, and he's going to return the next prefix expression along with the rest of the list. So he's going to give me back a to list. So he's going to hand me a suitcase. And in this suitcase, I'm going to open it up and I'm going to find on one half of it the first prefix expression. And the other half, I'm going to find what's left in the list after I extracted it. That sound like a reasonable plan? Okay, so easy part is if I'm looking at, if the car of this guy, might I be looking at an empty list? It really depends on under what circumstances I call this dude, right? I might, if I control when I call this guy, and I say, you know, here I'm only going to pass it a list that contains prefix expressions, then I don't have to worry about it. But it's probably not going to hurt us to worry about it. Worst that happens, we return the empty list and never use it, right? So we'll go ahead and throw a cond in here. And we'll have null prefix list. All right, and if we have a null prefix list, we're just going to go ahead and return empty list. I have nothing to give you. Okay, we might revisit that depending on how we glue the other pieces together. Let's leave it like that for right now. Otherwise, I must have something in that list. So I'm interested in whether or not the very first element, because our potential elements are integers or prefix expressions, right? Diff expressions. So the number is the easy one. So if the car of my prefix list is a number, this is the easy case, then I want to boil down to a list containing the car of my prefix list as well as the cooter of my prefix list. Something like that. Right? We're not annotating this yet. We're not adding any metadata. We potentially could come back in here and add metadata at this point, but let's just give ourselves the tool that allows us to extract pieces. All right? So solve it in the simplest way first, even if it takes more steps, and then we can decide if we can compress it down. All right, so that's the case if I'm looking at a number. I'm going to hand back that suitcase whose car is the number and whose cooter is all the other stuff I didn't use. Make sense? Okay, so now we're in our else. So this is where things get interesting. If it's not a number, it must be a what do we call it? Diff expression or prefix, whatever. Yeah, diff expression. If it's not a number, it must be a diff expression. And what do I do with diff expressions? Well, what's the car of a diff expression always going to look like? A what? Okay, well, it's always going to be the minus sign, right? Minus sign is always going to be the car. Okay, so I know I'm going to have a minus sign. Well, now let's think about what the components of our suitcase should look like. All right, so when am I going to call this function? I'm going to call this function when I need to get the next complete expression from the next complete prefix expression from a list. So I want it to kind of hand me back the entire expression. Now, we can maybe make the argument that we can go ahead and actually do the parsing in here. Not a great reason why we can't yet. Okay, let's start off where I'm going to say, I know I'm going to give you something that's going to have a minus sign first. I'm going to give you a list that's going to have a minus sign. But what we're going to cons onto that list is going to be whatever, because now I expect two sides, right? I need to get the next guy, and then from that, I need to get the next guy. So I need to get two guys, right? So whenever I see a diff expression, I need to get the next expression, and then get the next expression from what's left. How do I pull that off? Well, don't we have something called get next prefix expression? So do we want this guy to maybe return lists of lists? Potentially. We could have a list where the first list, so else I'm going to return a list whose first element, and we can just put a minus sign if we want, rather than take the car out. So we know it's going to be a minus sign. And then what I want to do is I want to get the next prefix expression from the coder. Correct? So we'll say get next prefix expression from the coder of my prefix list. Then what do I want to do? What's the second part of this?
Get the next one.
Get the next one. How do I get the next one? Don't I need to know what the coder of whatever this dude returns is? Because isn't that the list of prefix expressions that I would be extracting my next one from? So how do I do that? How do I get the result of this guy and use it to give me, to be able to make this next recursive call? I think this is the first time we've bumped into this problem, right? Well, this is the first time we've directly bumped into this problem. We've actually indirectly seen it before. I need the result of something before I can call it again. How do I do that? How do I temporarily store the result of a value in Scheme? Do we need a variable environment of some type? Do we have a way in Scheme of creating a local variable environment? I guess we could use our own, but we're not passing it through here. What about a let? Does a let us pull this off? Does a let us pull this off? So really what we're going to do here is in this else, before I create this list, I'm going to steal this guy right quick. I'm going to create a let. So I'm going to say let, and I'm going to have a let environment. And I'm going to say, we'll call this guy components. I don't want to spell that. Result. Let result equal the result of calling get next prefix expression on that stuff. And that's what's going to be stored in my let. Now I'm in the body of that let. When I'm in the body of that let, what do? Where is my first prefix expression going to be stored in my result? At least seemingly the way we've been building this. Is it going to be the car of result? Car of the result is going to hold my first prefix expression. Okay. So we're going to create a list containing a minus, containing the car of result, and then I need to go ahead and call get next prefix expression on the catter of result. Make sense? The second element in the result. Get next prefix expression on the getter of result. All right, so I'll create a list out of that. Now, how many times deep do we go in here? Well, who knows? But let's kind of trace through this with our current example and see what this is ultimately going to do for us. Okay? So I'm going to actually steal our example from here so we can trace it. All right, so that's what the example currently looks like. So we're going to call this guy on this prefix list. And we're going to ask Con, is it the empty list? Nope. Is the car a number? Nope. Else, we're going to create a variable called result. Okay, and result is going to equal the get next prefix expression on the footer of prefix list. So that's going to give us everything but, so we're going to call it on this piece. Okay, that's going to be our first result. The result of calling our function on that guy. All right, so we're going to hold that for a second. We're going to get to it again, right? So we're going to have another copy of this. So we're going to have a second result. Second result is going to be calling our list on, or calling our get next prefix expression on that guy. Okay? What's the next prefix expression on that guy? What's that going to boil down to? What will this turn into for me? The two lists containing a 3 and containing I have an extra parenthesis here, right? Containing that. Make sense? That's what that guy's going to turn into. So I didn't make another recursive call. I boiled down, result boiled down to this. So it got me my left thing there. So now that's what result is going to be at this level. So now I'm into the body of this let. Okay, what does the body of this let say to do? The body of this let says to create a list containing a dash. So here's my list. It's going to be my to list. The first element is going to be the dash, followed by the result of calling it on the rest of this list. So the result of that guy, well, actually, it's the car result, right? So the car is a 3. So that's my car. And then the getter is going to, or the getter is going to be this piece. So I want to get the get next prefix expression on that guy. So I'm going to steal that guy right here. This call has now completed, correct? And now I'm into another call, another recursive call. So I'm in result on that dude. That guy's going to boil down to the list containing a 2 and this stuff. Okay, so that's what result will be that time. So I'm waiting for get next. So I'm still up in this one here. So get next prefix expression on that guy was the, what was that? The 3, then the 2. I skipped a step here. Hold on a second. Let me back up to my last recursive call. I think I deleted it too soon. So there's my 3. There's the rest of the list. The list originally looks like, okay, I missed the minus. That didn't copy through here. I had 2 minuses. Oh, I removed it the second time. So let's back up to this step here. I had 2, but I burned through both of them in one step. So once I got into my original else here, I knew I was dealing with one of those kinds of expressions. So I was left with something that looked like this, which I did represent correctly here, but then I ignored it when I went down to the next step. Okay, so I have something that looks like this. So I'm still waiting on my result from this guy. And inside there, I'm going to see that, oh, the car of this is a minus. So I'm going to be in this else again. So that's where I'm going to get another result. My next result is going to be this guy. So I want to get the car of that. And I'm going to use that inside here. So this is where I skipped this line. I deleted it too soon. So this guy is going to produce for me the list containing a 3 followed by this list. Okay, so now I'm in the body of this let. So what am I going to do inside the body of that let? I'm going to produce the list containing a minus followed by the car of this guy, which is my 3, followed by whatever is returned by getNextPrefix on that guy. Okay, so I have to wait for another recursive call, getNextPrefix on, I'll keep these as comments here. GetNextPrefix on this dude is going to boil down to what? That's going to boil down to something that looks like a 2 followed by this list. So now I have a 2 followed by this list. So I really want the car of what comes out of this for my next element. But then how do I get the second part of my list? Do I need another let environment? So I actually have 2 pieces of information I need to remember. So I have lets inside of lets. Might a better let environment work for this? I think I'd previously mentioned we have a second kind of let called a let star. And I actually mentioned we have 3 different kinds of lets. We have a let star, and a let rec. Did anybody use a let star for their solution? Actually, interesting question. Obviously, I'm taking you down a let direction here. How many of you did this without using a let? Okay. How many of you did use a let for this? Nobody used a let.
So we are allowed to use those.
Huh?
We are allowed.
Yeah, we've introduced lets.
Okay, I just wasn't sure if we were allowed to. I know we introduced them. I wasn't sure if we were allowed to.
Yeah. This isn't necessarily the best way of writing this, but clearly we're moving into a let. We're going to be using lets quite a bit. We need these local environments. All right, so we're kind of drilling on these lets here. So the result of this call, we just keep this generic. The result of a getNextPrefix expression always gives me a 2 list. Doesn't it? It always gives me a 2 list. Well, now I have a problem. What do I do with that 2 list? I can't just create a list with this 2 list in it, because really only the car of this 2 list is the dude I want to have as the second part of this list. I need the catter of that list to be able to make another recursive call to kind of keep going. So if we think about what we ultimately want to get out of this, I have my minus, I have my 3 here at this level. Now I'm waiting to get the result of the next element from this one. I know I want my 2. That's the car of that result. That's the result I'm going to get from it. So I know I ultimately want a 2 here. But now this is going to be the result of calling the rest of the stuff. So when I get my my 3 and my 2, this is the actual next prefix expression, right? Looks like that. We've gone down the list here. and we finally hit that prefix expression. And now I'm able to bounce back up. Okay? But what do I need to deliver when I bounce back up? The rest of the stuff I've kind of moved through already. So the second half of this guy is ultimately going to be part of a to list. Okay, he's going to be part of a to list, and the second part of that to list is going to be the leftover crap. So here's the car of that, which is the next prefix. The cater of that is the rest of the stuff I have left that I can now continue to use that hasn't been used before. So what I really need here is the car of this result. But ultimately, I want to boil down to this guy needs to produce for me a to list, doesn't it? Right now, as we have it written, we're only producing the first part of that list. So this is, so if we don't want to use a second let, if we're just going to say that for a second, I can say, give me the car of this. Okay? So give me the car of this. That ends my first list. Now, I want to make another list out of this. The first element of that list will be this dude. The second element of that list will be the cater of whatever's returned by this guy. So that's my to list, right? The first list is my prefix expression. The second thing in there is what I have left. Does this seem inefficient to you? I'm actually calling getNext prefix expression on the absolute identical input twice. That should probably tell us if we're going to do something twice, store it in a variable. Got a reasonable rule of thumb that we've learned in Java and other languages. Okay, so I'm not going to actually create this list yet. Instead, I'm going to have a second let. So I'm going to introduce the other kind of let after I show you the crazy way of writing this. So here is the end of my, this is the let environment. This is the let body that I'm in here. Inside my let body, I'm actually going to create another let. So I'm going to have another let, and we're going to call this guy result2. Okay, we'll call this guy result2. And result2 is going to be the result of calling that guy copy too much. Result2 will be the result of calling that guy on the scatter of result. Okay, so there's the end of that let. Now, in this let body, so now this is an environment inside of an environment. I'm two scopes in. I actually have access to two variables. I have a variable called result, and I have a variable called result2. Correct? Result holds the stuff about the first list expression. Result2 is implemented in terms of the value of result. Lets do not let you pull that off. Pun intended, I think. Okay, so in a normal let, you cannot use one of your other variables in the expression for another one of your variables you're defining. It doesn't allow that. So that's why we had to split this between two lets. give me this environment with this variable. Now I can use that variable inside this new environment where I'll create another let and give myself a second variable that now I can define in terms of my first variable. That make sense? Okay, so now I'm here. When I'm in here, I now have access to both result and to result2. Now I can go ahead and I can create my list. Now remember, the job of this guy is to return a to list because that's what getNext prefix expression always returns, is a to list. Make sense? So he's going to be a list whose first element is going to be my diff list, the minus, having the car of the result, which is going to be the left-hand side, and then this guy, let me just get rid of that piece. This is going to be the car of result 2. Correct? That's going to give me my the resulting prefix list, prefix expression from this guy. And what's the second part of this guy going to be? What's left? What's left is the catter of result 2. So let me burn through this. So there's my to list, whose first element is my diff list, and whose second element is the rest of the stuff I have left over, which somebody else will then end up using. There's the end of my second let, there's the end of my else, there's the end of my con, there's the end of my lambda, there's the end of my define. Make sense? So this function in terms of multiple lets is going to give us our kind of components that we are going to end up needing for this. So if we walk through this now in our last couple minutes, and then we'll write the second half of this on Monday. If we walk through this now, we have our original thing here. We got into our second version of this. Result was equal to result ultimately would be equal to, this is our first result. Our first result ultimately is going to equal a to list whose first element is going to be a minus, whose second element, whose first element is going to be minus, followed by the promise of the rest of this stuff. So I should get out of this another minus, and a 3, and a 2, like that. And that's the end of that guy. And then the rest of my list is going to contain the minus, the 4, the minus, the 12, and the 7. That's going to be the second part of that to list. So this is where I'll find the rest of my stuff from my second diff expression. That make sense? I'm getting that from the two different results. All right, so I'm going to pause this here since we're out of time. What I do want you to do, so we'll see this actually work next time, but this guy will create these two lists. What I want you to see, look at for next time is if you scroll down a little bit into chapter 3, we start dealing with expressions. I want you to read through, so read in chapter 3 through through page 60. This will introduce our next kind of more grown-up language, this language of expressions. So now we're taking our lambda calculus expression and taking it to a little bit different level where we have, here's conditionals and identifiers, and we also will even support our own lets, which we'll probably use our own variable environment internally for. Make sense? All right, I'll see everybody on Monday. One